Assalamualaikum warahmatullahi wabarakatuh. My name is Q1 Alma Kamelia binti Wan AZHAR, and today I want to present Leg 1. So here is the list of exercise. Question 1 is write a program that will store 0 times 30 into R0, copy the content of R0 into R5, and then save data 0 times 4578561 into memory location 0 times 40000030. Execute the program and explain the differences in the results. Also discuss the addressing modes of each instruction used. So now I want to proceed to the kill software for question 1. So this is the program. Click the boot. And first and foremost, we need to make sure there is no errors, and then we can proceed to debug. Okay, after that we have to run to cursor line and then highlight this one. Okay, so to click. So now we set up the R0 into 0 times 000000030. After that, click step again. R5 will be the same value as R0, which is 0 times 0000030. After that, R1 is 0 times 4578561 and then R2 is 0 times 40000030. So for STR, in memory location, we need to put the address of R2 into this space. So we will see the address of R1 in the memory location, which is 12, 56, 78, and 45. So that's the question 1. So now I want to discuss the instruction modes of each instruction used in the program. First and foremost, for instruction number 5 is immediate addressing. Instruction number 6 is indirect addressing, immediate offset. Instruction number 7 is immediate offset. Instruction number 8 is immediate offset. Instruction number 9 is indirect addressing, immediate offset. Okay, now I want to proceed to the question number 2. Write and execute a program that will add 0 times 20FE5690, 0 times FE123089, and 0 times 34589710, and save the sum in register R7. Record the change in CPSR as well. So we go back to the kill software. So here is the question 2 programmer, and then click the boot and make sure there is no errors, then we can proceed to debug. After that, make sure this is lined up, and then click the cursor line, highlight this one. So before we starting the program, we need to bear in mind that this is the before value of register this is their addressing. Okay, so we set up the R0 is 0 times 20FE5690, and then for R1 we set up to 2 times FE123089, and then R2 0 times 34589710. So for R3, it is the add instruction. So which is R0 plus R1 equal to R3. So we will get R3 is 0 times 1F1 08719. So for R7, we use X instruction, which is R2 plus R3. So we could get 0 times 5369 1E29. So we could see the NZCV over here. So proceed to question number 3. Write a program that will store 0 times 2936 FEDA in R8 and then perform the following instruction on the content of that register 4 times. Comment on your result. So here is the question number 4. So this is the programmer. Question number 3. Okay. This is the programmer. So first and foremost, we need to build and make sure there is 0 errors. After that, we need to debug. And then click the run to cursor line. This one. And then we set up the R8 to 0 times 2936 FEDA. Okay, it will appear like this. After that, R1 is 0 times 0 times 02936 FED. And then 0 times for R2, 0 times 936 FED A0. After that, for R3, for the ASR, R1, we need to use the calculator. We need to check it on calculator, which is we need to set up the heads and then put the R8, which is 2936 FEDA, and ASR, which is arithmetic shift, and then click right, and 4 equal to 293 CFED. 293 CFED. After that, for LSL, which is logical shift left, and then we need to change this one to logical shift, and then put the R8 again, 2936 FE DA, click left, 4 equal to okay, R2 is 936 FEDA0. 936 FEDA0. Okay. So for R3, we got A2936 FED, which is we cannot use this calculator, and it was failed, and I used in Google calculator, which is we put the R8 value 293 CFEDA. The size is 32. Shift is 4, and then right, and then circular shift ROR, and then perform bit shift operation. So we could see the answer of hex A2936 FED. After that, that's all for question number 3. And then we proceed to the question number 4. Write a program that will perform logical or 0 times 6398 with 0 times 1 DFE. Execute the program and comment on the result. So we proceed to the kill software for question 4. This is the programmer, and then we boot it. Make sure there is no error, and then debug. Wait a second. There is a technical. Oh, alah lah. Oh.